Hello everyone, this is Ryan Kinchin with High Desert Math Tutor, and today I'm going to take a moment to talk to you about the fundamental algebra required for the ASVAB. Now, both the arithmetic reasoning and the math knowledge portions of the ASVAB require you to know some amount of algebra. But before we can really jump into the algebra, we need to make sure we understand the order of operations, also known as PEMDAS. So anytime we're going to do a calculation, such as, say, 2 times 3 plus 1, if we wanted to calculate this, we have to follow the order of operations. Now, the order of operations starts with parentheses. It says any sort of calculation that has parentheses involved, you want to simplify what's inside the parentheses first. So an example of this, let's say we had 2 times 3 plus 1. Well, these are the parentheses, so we need to simplify 3 plus 1 before we multiply. So we'll get 2 times 3 plus 1 is 4, and 2 times 4 is 8. So the first step is to simplify anything within parentheses. After you do that, you can move on to exponents, which exponents are the small numbers at the top right of a number or a variable. For example, so you had 2 to the power 3. This 3 right here is called an exponent. What that is telling us to do, it says take the number 2 and multiply it by itself 3 times. One way of saying this is cube the number 2 or raise the number 2 to the power 3. When we do this, we get 2 times 2 is 4. Carry down the last 2. And 4 times 2 is 8. So we start by simplifying anything within parentheses. We move on to simplifying any exponents we see in our calculation. Then we move on to multiplication and division. But notice that multiplication and division are the same color. The reason for that is because multiplication and division have the same level of importance in computation and math. So multiplication is the opposite of division. So the rule here is do whichever one comes first from left to right. So what we can do is say we had 4 divided by 2 times 3. Well, we start with multiplication or division, whichever comes first. Since from left to right, division is the first thing we see, we're going to divide 4 by 2 in the very beginning. So 4 divided by 2 is 2. Then we're going to copy over the times 3. And 2 times 3 is 6. So simplifying, we begin by simplifying any computations inside of parentheses. We then move on to simplifying exponents. Thereafter, we deal with multiplication and division, whichever one comes first from left to right. Then we go on to addition and subtraction. And the same thing with addition and subtraction. Subtraction is the opposite of addition. And addition and subtraction both have the same level of importance in the order of operations. So we do whichever one comes first from left to right. So that one's self-explanatory enough. So getting back to our initial example right here, when we have a mixture of multiplication, division, exponents, and parentheses, we have to follow the order of operations. So we start at the very top of the order of operations and we work our way down. So we have 2 times 3 plus 1. So we don't have any parentheses, we do not have any exponents, but we do have multiplication. So the first thing we're going to do is simplify 2 times 3. So 2 times 3 is 6. But now we need to deal with the plus 1. So we add plus 1. Now 6 plus 1 is 7. Now one more example of the order of operations that's slightly more complicated. Let's say we had 2 times 5 minus 3 to the power 2 minus 4. So here, this one has a little bit of everything involved. So we need to go to the order of operations. And the first step is parentheses. So we deal with whatever's inside the parentheses first. So 5 minus 3 is 2. So I'm going to rewrite this whole thing, but instead of writing 5 minus 3 inside of parentheses, I'm going to replace that with the simpler number 2. So we have 2 times, now where the parentheses would be, we have 2 squared, minus 4. So remember, right here, the 5 minus 3 has now been simplified to this 2. So we've taken care of all the parentheses in this expression. So next we move on to exponents. So the exponent up here, 2, is telling us to take this 2 and multiply it by itself. So here, 2 to the power 2 is the same as 2 times 2, which is equal to 4. So 2 to the power 2 is 4. We still have to copy down this minus 4 from above. So we've taken care of parentheses. We've taken care of exponents. Now we need to go on to multiplication, division, and then addition and subtraction. So 2 times 4 is 8. And we did that before subtracting 4. And finally, 8 minus 4 is 4. So any time you ever simplify an expression in math, you're going to have to follow the order of operations. But algebra is not about simplifying expressions. It's about undoing expressions so that you can get something you're interested in by itself. This is very important because in many math problems, for the ASVAB especially, you'll come across problems such as percentage problems, rate problems, where it's rate times time equals distance. And an example of percentage also would be percent times whole equals part. So you have percentage problems that have percent times whole equals part. You have rate, time, distance problems where it's rate times time equals distance. And there are many other examples. There could be rate times amount equals total, and many other formulas of that nature. So the one common theme with all these formulas is that's a relationship we have to commit to just memorizing. But then when it comes time to do a problem in, say, arithmetic reasoning, we have to recall this formula, but we also have to know how to work with it using algebra. So a quick little example of where we would see these formulas and then also how the algebra comes into play. Say we had a problem. Say we were driving 60 miles an hour. And say that we were driving at this speed for, let's say, 3 hours. We could take one of these formulas, say that rate times time equals distance, and plug these values directly into the formula. So 60 miles per hour is a rate. So where we have rate, we're going to replace rate with 60. Now 3 hours is how long we've been driving, so we're going to replace time with 3. And after we multiply this out, 60 times 3. 3 times 0 is 0. 3 times 6 is 18. This tells us we will have gone 180 miles after driving for 3 hours at 60 miles an hour. But when the algebra comes in is when we have the same formula, but we're given, say, the rate and the distance, but not the time. An example of this, let's say, get some other colors going. Let's say instead of driving 60 miles per hour for 3 hours, let's say we were driving let's say that we drove 150 miles. But we did this at a rate of 75 miles per hour. Now the question I have for you is, how many hours were we driving? Well, this is a very similar question to the one above, but it's not as nice as the one above, because if you notice the formula, it has rate times time equals distance. And when we plug in these numbers, we'll have a rate of 75 miles an hour and a distance of 150 miles. But we don't know the time, and the time is not by itself. We don't simply plug these numbers in and compute. We need to actually get time by itself so we know how much time it takes us to drive this distance at this speed. So what this requires us to do is use algebra to undo whatever is happening to time to get time by itself. So the key to algebra is understanding the equal sign. The equal sign tells us that whatever's on the left side of the equation, no matter what it looks like, it has exactly the same numerical value as what's on the right side of the equation. And with that in mind, if we were to add something to this side, say add 5, this would be the same as the other side if we also added 5 to the other side. So we need to make sure that we maintain balance with equations. But when you're working with algebra, the goal is to manipulate this equation so that we get the thing we want by itself. And we do that by strategically undoing the things in the equation that we no longer want or need. So if we look over here, what are we doing to time? We are multiplying time by 75. Now, if we go back up to the order of operations, multiplication had a counterpart, which was division. Division is the opposite of multiplication. So what we must do to get time by itself is cancel out this multiplication by 75. And the opposite of multiplying by 75 is dividing by 75. So we're going to divide by 75 to undo this multiplication by 75. But remember, if we do something to one side of the equation, we have to do it to the other. So now time times 75 divided by 75 cancels out. So all that's left on this side of the equation is time. But now we have to do one more thing. We need to ask ourselves, what is 150 divided by 75? So anytime we're dividing, the number that's being divided has to go inside the long division bar. So 150 divided by 75. We begin by asking, how many times does 75 go into 1? The answer is 0 times. Next, how many times does 75 go into 15? The answer is 0 times. So now we need to do a little more work and ask, okay, how many times does 75 go into 150? So let's do some scratch work. So 75 times 1 is 75. Okay, what about 75 times 2? Well, 75 times 2. 2 times 5 is 10. So put the 1 up top and the 0 on the bottom. 2 times 7 is 14. Plus 1 is 15. So 75 times 2 is 150. So that's exactly what we needed. So 75 goes into 150 2 times. And 75 times 2 is 150. So we're going to subtract that. And 150 minus 150 is 0. So 75 goes into 150 exactly 2 times. And what this tells us is that the time it took for us to drive 150 miles going 75 miles per hour was exactly 2 hours. So we covered a lot of information without explicitly discussing what it takes to do algebra. So let's take one more look at our order of operations. So when we're following the order of operations to simplify computation, we always go from top down. We simplify parentheses. After all parentheses have been simplified, we simplify exponents. When parentheses and exponents are simplified, we go on to multiplication and division from left to right. Then we go on to addition and subtraction from left to right. Now, if we have a goal, say we wanted to make $150, and we were making $10 an hour. Well, we make $10 every hour, so we're going to do 10 times the number of hours we work. And finally, let's say that we are going to start a new job, and that job is starting us off with a $50 bonus. But other than that one-time $50 bonus, we're going to make $10 every hour that we work. Well, our goal is to make $150, but we don't know how many hours it's going to take us to work to actually achieve our goal. So we have this situation set up, basically a goal. And what we want to know is how many hours do we actually have to work to achieve this goal? This is a situation where algebra comes into play. So notice that we have an equation right here. You can only do algebra if you have an equation. So going through this equation, if we knew what h was, we would simply plug in a number here, such as say h was 3. We'd plug in 3, and we could actually simplify this expression right here. But since we don't know what h is, we can't simply plug in a number and simplify like we had before. So what we need to do is undo everything that is around h until it's by itself. But when we're undoing this work, we're going to do it by going through the order of operations, PEMDAS, backwards. So we'll begin by looking at the equation, asking, is there any addition or subtraction happening to h? And we can see that we're currently adding 50 to h. So we want that to go away. So the opposite of adding is subtracting. So we're going to subtract 50. But if we subtract 50 from the left side of the equation, we need to subtract 50 from the right side of the equation. So when you add and subtract the same number, that cancels out. So all that's left on the left side is 10h. But on the right side, we have 150 minus 50. So all that's left is 100. Next, we are done with addition and subtraction. We have 10 touching the letter h. Anytime a number is just touching a variable or a letter, the operation is multiplication. So we're currently multiplying h by 10. So how do we get rid of that? We have to notice that the opposite of multiplication is division. So instead of multiplying by 10, we are going to divide by 10. But if we do it to one side of the equation, we have to divide the other side of the equation by 10. So here, these 10s cancel out, and all that's left on the left side of the equation is h. But for the right side of the equation, we have 100 divided by 10. Now, we do this one more time with long division. So the number that's being divided goes inside the long division bar. The number we're dividing by goes outside. So the question now is, how many times does 10 go into 1? 10 goes into 1 0 times. Well, how many times does 10 go into 10? 10 goes into 10 exactly one time. So 1 times 10 is 10. So we subtract that. 10 minus 10 is 0. We can bring down this other 0. And now 10 goes into 0 times. So 10 times 0 is 0. We subtract that, and we're officially done. So here we see that our answer is 10. And what we have found is that we have to work 10 hours at $10 an hour if we start a new job that gives us a one-time $50 bonus, and if our goal is to make $150. So this was a rough video, but I hope it's helpful. If you have questions for any of your ASVAB studies, leave a comment down below and tell me what you need. You know, I'm here to help. So on your way out, please like and subscribe, and we'll see you next time.